Welcome to our last video of Chapter 8. This is a continuation of applications, so it's going to be more applications. It is absolutely essential that you have a calculator for today's video. You will not be able to do this video without a calculator. Okay, so there are two equations we need to know. These are actually equations we've already talked about. So in this case, we're going to go over what are those two equations, and then we're going to use them in some problems. We're going to be looking at exponential growth and decay. Exponential growth or decay can be continuous or not. If it's non-continuous exponential growth or decay, we use the formula that we learned at the very beginning of the chapter. Y equals P times the quantity 1 plus or minus R over N to the power NT. Okay, R stands for rate, T stands for time. Often the time will be in years, but it could be minutes, months, days. N is the number of times per year that were compounded, and P is the principal amount. Quick note for us. Oftentimes n is going to be equal to 1, except in the case of interest. So n is often 1 except in the case of interest. So that's our first equation. Then we have the continuous equation, which we learned in the last video. That's PE to the RT. You also might see it written as y equals PE to the KT. You might see either one. And K in this case, or R, is a constant. P is still the principal. E, remember, is a constant. It's a number in the calculator. T is still time. Today's video, we're going to need to determine when to use each of these equations. Okay. What's most important is whether or not we're continuous. So I think it's best if we just jump in and do some examples together. Let's look at example number 1. It says you have 50 grams of carbon-14 that decays at 13.5% per year. How many years will it take for 1/5 of the original amount to remain? So the question is, how do we know if this is continuous? If the question is continuous, it will say continuous. We don't see continuous, we see per year. Per year means it happens once a year. So we're going to be using the first equation. Okay, so again, you're only going to use the second equation if the problem says continuous. So let's see what information we have. It says 50 grams. That's what we're starting with. 13.5% is our rate. Per year tells us it's once a year. How many years tells us that we're looking for T? Will it take for 1/5 of the original amount to remain? Okay, if we're looking for T, that means we should know all of the other numbers. If we're looking for T, we should know all of the other numbers. So let's plug in what we know. We know we have 50 grams of carbon. We know our rate is 13.5%, except we're not going to put in 13.5. It needs to be as a decimal. So that'll be 0.135. N is 1, because it's once a year, times T. Okay, a few things we need to decide right now. We need to decide, are we doing positive or negative? Are we adding or subtracting? And do we have y? Or what is the value of y? If something is getting bigger, we're going to be adding. If we're going to end up with more than what we had, should get bigger. We should be adding. In this case, we're talking about decay. Decay means we're subtracting. It means the amount that we're starting with is going to get smaller as time goes on. So we're going to subtract. We have to know y if we're looking for T. We've talked about we can only have one unknown in an equation, so we must know y. Well, it says 1/5 of the amount to remain. 1/5 of the amount to remain. If I'm starting with 50 grams, 1/5 of that is 10. So I want to know, when am I going to have 10 grams left? Okay, I'm going to do a little simplifying first. I'm going to put this in my calculator, that 1 minus 0.135 over 1, and I will tell you that that ends up being 0.865. And 1 times t is just t. Okay, so I can divide both sides by 50. 10 divided by 50 is 1/5, and then I get 0.865 to the t. Okay, we got to think here. We cannot divide by 0.865. That doesn't work. We cannot divide by 0.865, so don't try that. In this case, we're stuck. So in the previous video, when we were stuck, what did we do? Well, we tried to take the log of both sides. So we're going to take the log of both sides and see if that helps. We get log of 1/5 is equal to log of 0.865 to the t. And then we said, yeah, this does help. Property of logs, I can bring the t out in front. So I get log of 1/5 is equal to t times the log of 0.865. If t is what I'm looking for, I can divide then by that log of 0.865. Okay, please remember, those logs do not cancel out. Those logs do not cancel out. You're going to type this in your calculator exactly how it looks. Remember to put that 1/5 in parentheses. Okay, so hopefully you did that. You should get about 11.10 years. So in just over 11 years, we're going to have 1/5 of the original amount. Okay, let's look at another example. Example number 2. Example number 2 says you put $2,000 in a bank account that pays 3% interest compounded continuously. How many years will it take for the amount in the account to double? So I told us, if we're going to use the continuous equation, it's going to say continuous. It says continuous, so we're going to use y equals PE to the RT or KT. Let's look at what we have. $2,000, that is our P, that's our principal amount. 3% is our R. How many years? Tells us that we're looking for T again, for our account to double. Okay, so let's plug all that in. Our principal amount is $2,000. E, if our rate is 3%, remember we're going to use 0.03 T. Now again, like the last example, we can only have one unknown. So if we're looking for T, we have to know what Y is. Y is the balance or the amount after a certain time. We're looking for our account to double. So if we put 2,000 in initially, when we double, we'll have 4,000 in the account. Okay, so I'm going to divide by 2,000. I get 2 equals E to the 0.03 T. Okay, so at this point, we're stuck. You can't divide by E. Remember, you can't divide by E. So try to take the log of both sides and see if that helps. We get log of 2 is equal to log of E to the 0.03 T. So then remember, property of logs, that power comes out in front. Oops. So I get log of 2 is equal to 0.03 T times the log of E. So I can divide by the log of E. So I get log of 2 divided by log of E. Okay, so in your calculator, that's what you're going to plug in. You're going to plug in log of 2 divided by log of E. Remember, though, that's only 0.03 T, so we still have to divide by 0.03. I'm going to tell you, you get about 23.1 years. Now, I'm going to pull up my calculator real quick to show you those steps in case you need to see them. Okay, so we're going to hit log, of 2, make sure you end your parentheses, divided by log of e. And then again, that's not our final answer. We have to divide by 0.03. So if we just hit the division sign, it'll bring up that previous answer, and we can divide by 0.03. So hopefully that makes sense. If you need to rewind and go through the calculator part one more time, please do so. Okay, let's do another example. The half-life of a radioactive substance is the time that it takes for half of the atoms of the substance to disintegrate. The half-life of carbon-14 is 5,730 years. Determine the value of K and the equation of decay. Okay, this one doesn't say continuous, but it does say K. K tells us that this is continuous. And that should make sense. If we have a substance that's decaying, it's continuously decaying. It's continuously decaying. So let's see what we know. We know the number of years. That's our T. It's telling us to find K. So we know we're using this equation, y equals PE to the KT or RT, either one. We are also told the half-life. Half-life is the amount of time it takes for half to remain. We're not told a principal amount, though. That's okay, we can choose our principal amount. Let's say we choose a principal amount of 100 grams. That means when half remains, it's going to be 50 grams. Okay, so let's go to our equation. P is that 100 grams. K is what we're looking for. And our T is 5,730. So then Y, our amount after a certain amount of time, is going to be 50. Right? That's our half-life. If we started with 100 grams, after one half-life, after 5,730 years, half of the amount will remain. So I'm going to divide by 100. 50 divided by 100 is 0.5. And I get e to the power k times 5,730. Okay, so we need to find k and the equation. At this point, we're stuck in the form that we're in, so try taking the log of both sides and see if that helps. When we do that, we get log of 0.5 is equal to log of e to the power k times 5,730. We've talked about that power property of logs can come out in front. So we end up with log of 0.5 is equal to k times 5,730 log of e. If k is what I want, I'm going to divide by everything that I don't want. So I'm going to divide by that 5,730 log of e. Okay, now, this is a little tricky to put in the calculator. That denominator needs to be in parentheses, because we need to tell the calculator that we want to divide by everything. So right now, type this into your calculator, and you should get negative 1.2 times 10 to the negative fourth. So that's scientific notation. In your calculator, you're going to see an E, which tells us we're doing scientific notation. So we're going to move that decimal point over. That's really negative 0.00012. Okay, why is this negative? Well, the negative should make sense. Our carbon is decaying. That's why we have a negative K. Decaying, we're going to have a negative K. If it were growing, we would have a positive K. So that's our value of K, and then we need the equation of decay. So our equation ends up being y equals P E to the negative 0.00012 T. Okay, so how would this equation be used? If we have a principal amount, so we have 1,000 grams of this substance or 500 grams of this substance, we could put in P, however much we have, and we could put in an amount of time, and it would tell us how much would remain after that amount of time. So we could put in 1,000, and it would tell us after 1,000 years how much of that substance would remain. Okay, next page, you have an example to do on your own. Example number 4 is one for you to try. You buy a new car for $23,000. The value of the car depreciates at a rate of $16,000 per year. Write a model, and then when will the car have a value of $15,000? So I am going to help us out, help us determine which equation to use. It says depreciates at a rate of 16,000 or 16% per year. That per year tells us that n equals 1 time a year. This is not continuous. This is not continuous. So the general equation would be P 1 plus or minus R over N to the NT. This is the equation that you're going to use. So plug in what you know in part A. Part B, you're going to use your equation. I will tell you when it says write a model, your model should have Y and it should have T as variables. So you should end up with an equation that has a Y and a T. All the other numbers should be filled in. Okay, so stop the video, try this one on your own, and come back when you are ready, please. Okay, part B, I'm going to tell you you should have gotten an answer of 2.45 years. 2.45 years. Okay, that is the end of the required part of the video. If you want one extra example, stay on and we'll do this extra example. If you think you've got it and you know what you're doing, then I will see you in class. Okay, example 5. A type of bacteria is growing exponentially according to the model y equals 1,000 e to the kt, where t is the time in minutes. If there are 1,000 cells initially and 1,650 cells after 40 minutes, find the value of k. Okay, find the value of k. Tells us this is continuous. Tells us there are 1,000 cells initially. That is our principal amount. 40 minutes is time, and then we have how many cells there are after that amount of time. So our model is y equals 1,000 e to the kt. If we're finding k, that means we need to know t and y, which is good because we have those here. After 40 minutes, this is how many remain. So that's what we're going to substitute in. We get 1,650 is equal to 1,000 e to the 40k. So a lot of times t will be in terms of years. In this case, though, t is in terms of minutes, which is fine. Okay, so we're going to divide by 1,000. On the left side, I get 1.65 is equal to e to the 40k. We've talked about if you're stuck in the form that you're in, take the log of both sides. So I get log of 1.65 is equal to log of e to the 40k. That power is going to come out in front. So I have log of 1.65 is equal to 40k times the log of e. If I'm looking for k, I can divide by everything I don't want on the right side. I don't want that 40, I don't want that log of e. So my k ends up being log of 1.65 divided by 40 times the log of e. This is the one that we got to be really careful about. In the calculator, has to be in parentheses. What you could also do is you could do log of 1.65 divided by log of e, and then whatever you get, you could divide by 40. That will work as well. But we have to make sure we divide by both log of e and 40. When we do, we should get k to be about 0.0125. So we got to ask ourselves, does that make sense? Does it make sense to have a positive k? Yes. How do we know? The bacteria is growing. So we've talked about If we have decay, that k will be negative. If we have growth, that k will be positive. So hopefully this extra example helped. If you have any questions, please make sure that you write them down so you can ask in class or send me an email.